On this side, welcome back to the channel. So till now, we have covered the refresh scope and how we can do dynamic refresh. But we end that topic like this question. Let's say that this is something which we have already covered. Okay. And in the config server, we have invoke /actuator/refresh. And we have 100 of microservices which are fetching the properties from the config server. So our question was, do I have to invoke actuator/refresh for all of these 100 of microservices? So currently answer is yes, like whatever the approach we were using. So we were using actuator/refresh way, right? So we were calling this API, okay, over the config servers, and we have to invoke this endpoint at all microservices. Then only our dynamic refresh will work. And also we have ended that this can be resolved through Spring Cloud Bus. And that's where we are. Okay. So let's first see, before even jump to Spring Cloud Bus, let's first see how event is published within one application itself. So we are not talking about multiple microservices, distributed microservices. Within one application, how you publish an event and how it internally works, because these things are highly related. So see this, I created one event, my custom event. This is something which I want to publish to listeners. Okay, so let's understand this. I have a publisher and I have listeners, listener 1, listener 2, and so many listeners. So this my custom event is something which I want to publish to the listener. So a payload will go, let's say, and that payload is my custom event. Okay, so this payload will go. So you can say that this is my message which I want to send, and it should extend application event interface. So here when we do publish event, right, this publish event accept the type of this class, application event interface. So that's why whatever the message you have to create, it has to extend this. And here this is a simple constructor. Here we have to provide the source. This source is nothing but the information about who is publishing. So here let's say this is the publisher, this publisher details. So you can say that this is my source. So here I am passing this object. So all the information about this publisher, that's all. Okay. And the message is whatever the message we want to publish. So this could be like more fields which you want. So here currently I have only one field which I want to publish into my payload. So that's why I have only message, but you can have more. And this is just a getter. So this is very, very simple class of a event message which I want to publish. Now I have one bean of, let's say that my event publisher. So this is the publisher which is going to publish it. Okay. So I am using this application event publisher. So this is already present into the Spring framework. It is an interface, you can say that, which abstract the logic of publishing an event. Like it's not, there are a lot of things involved when publishing an event. So all those things are abstracted to us. All we have to do is we have to invoke this method publish event. That's all. I will tell you internally what it does. Okay. But for now, consider this. This is the interface which makes our job easy. We just have to invoke publish event. That's all. And we just have to pass our payload, or you can say that event which we have to publish. So that's why I have auto-wired this publisher object, application event publisher. And this is my publish method. Internally, I am using this publisher object and I'm calling just publish event. And this is my event or message, my custom event. So I'm creating a new object, my custom event. Source is like who is publishing. So this is the publisher, right? So source about this, and the message which I want to publish. Okay. So this is the simple publishing logic I have. So this is done. Now here listeners, we can have so many listeners. So I am just creating one listener. So here if you see, this is just a bean, like my event listener annotated with @component. So here I have created one listener, @event listener, and which event it is handling, any method name you can give. So I am handling my custom event. So this is listening to this. So similarly, we can have different listener listening to different events. Okay, so let's say event 2. So the listener 3 might be listening to this event 2 something. But this event which I am creating, it is listening to my custom event, this one. And once the event is received, this is just an object, right? So you can just access whatever you want to access. Okay, so here I am doing event.getMessage, and so that this message I can get. Okay, so here very important thing is that this is the very minimalistic code you required to test how event is published within one application. How it will work internally, I will tell you. So okay, so here I am just adding a normal controller just to test the flow. So here I auto wired this publisher. This is the publisher, right? So I have now its object here. Okay, and using this object I am invoking its publish message. This publish message method I am invoking so that this get invoked. So this is just to test the flow. And now from Postman I am just invoking this endpoint within app publish. So this endpoint I invoke, I pass the message hello world. Now what it will do, it will invoke our publisher publish method. So this one. So it invokes this method and pass the message hello world. Now it is doing publisher.publish event. It creates a new object and pass this. So here if you see the output, it says received event message hello world. So this is, we have printed here, receive event message hello world. So even though we have invoked this from the controller, it just published an event. It hasn't invoked this directly. So internally it is able to find this listener and invoking it properly. So how's it working? See this. It is very important to understand that one. So in the publisher, so we have a publisher. So we have multiple listener. Okay. So here this was our publisher and there we were publishing an event. So internally it goes to one of the helper class. So see, it internally goes to this class, simple application event multicaster.java. So this is the framework code. You can dig deeper into it. You can put a debugger point and see how it is working. So you will encounter this code. What it will do? It is iterating. It is iterating over a list of listeners. Okay. So here, what I'll tell you that when we create a listener like this, and when you start an application, internally it creates a list like this. Okay, my custom event, this is the event who is listening. So my event listener is listening. Listener 1, listener 2, listener 3. So for each event, it has a list of listeners who are listening. Okay, so it has complete detail about it, or which method need to be invoked. Okay, what are the parameters it required, like all the details. So it stores certain information that, okay, for this event, what are all the listeners I have to pass the or publish the event. So it is iterating over the list. And what list? Based on the type. So event type, whatever the event we have, its type we have. So based on that, it will get a list of all the listeners of it. And then it is invoking that listener. So here if you see, this is all the information you will get about a listener. So let's say the type is my custom event. This is the message type, right? This is the message type here. So I want to see that, hey, who is listening to this event? Because we have published this event. In publish event, we have published this my custom event. So I need to check who is listening to this event. So I am taking out a list based on that. Give me all the listeners who are listening to my custom event. So you get this kind of information. Here I'm zooming it. Hey, what's the bean name? What's the method name I have to invoke? Okay, so full details. It has all the target method keys, everything. Okay, about if there are, let's say 100 listener, it have all 100 listener information about it. Okay, and one by one it is invoking this listener. So one thing you got to know, that this is the flow. When you invoke a publish and pass an event, it internally goes to this multicaster, which iterate over this list of listeners, which it take out based on this event and invoke the method one by one. So it is very similar to observer design pattern in LLD. And it's all happening in the sync manner within an application. Within one application, this is the flow. But now we are talking about distributed microservices. Okay, microservices 1, which is act as a publisher. Now it has to broadcast an event to multiple microservices, which are act as, let's say, listeners or consumers. Now they are not within one application. So how it will work? That's where Spring Cloud Bus comes into the picture. But again, whatever we have understood about one application, that info, or you can say that logic is still there even in the Spring Cloud Bus. How? So see this, understand with this flow. Now let's say this is microservice A, which is currently acting as a publisher. It published an event. Now this event, earlier it was what? Where is our event? Yeah, so earlier it was application event. Whatever the my custom event, it extend application event. Now here, whatever the event we will pass, that would be a subclass of remote application event. Remote application event means it is not within a same class or same application. This event has to go to a remote destination somewhere. So using that, our Spring Cloud Bus intercepted. Once a Spring Cloud Bus intercepted, it make use of our message broker infrastructure. So our message broker, let's say RabbitMQ or Kafka, that should be present up and running. Okay, and whatever the logic, whatever the configuration we have, it's totally like should be present. Spring Cloud Bus only use it. It do not manage it. It only use it to send the message. So Spring Cloud Bus intercept your event, serialize it, put it into JSON form, and use your message broker and send the message. So internally it create, let's say you are using RabbitMQ, internally it will create a queue, it will create an exchange, and then it will bind it with a routing key. It will do everything which is abstracted to us. We don't even know. Okay. Only thing is we have to grant access to the Spring Cloud Bus. Hey, this is the message broker you can use. Internally, if let's say if you have Kafka, it will take care of creating the topic. Inside it will take care of creating the partition, everything. So everything is abstracted to us. We are not going to manage the message broker. Very important, I am saying you, we are not managing message broker with Spring Cloud Bus. Okay, so what's the retry mechanism? How you handle the failure? What are the offset handling? Nothing is managed by Spring Cloud Bus. It is just a layer which is used to just send a message, and it make use of message broker. Now message broker again pass it to the Spring Cloud Bus, which is in another application. Now it deserialize it. Deserialize it means JSON to Java object, and it passes to simple application event multicaster. So the same thing is happening, but here if you see, this publish event is present into one application. Now ultimately is reached to simple application event multicaster into different application, and from there it broadcast to the event listeners. So this is happening like it is publish event is coming from a same application. Simple application multicaster, like Okay, I am getting an event, maybe it is from the same application, but internally Spring Cloud Bus abstracted all the info. So from which microservice, how message broker is used, how it is, you can say that listening to the queue or topic, fetching it, and it only deserialize it and then pass it to the simple application event multicaster. So this flow is clear. So even though Spring Cloud Bus we are using, we had to understand how in one application it is working. That will give us better clarity. So Spring Cloud Bus abstract all the details regarding message broker. If you are using RabbitQMQ, we don't have to create exchange, we don't have to create queue, we don't have to bind the queue and exchange using routing key. Everything is decided by Spring Cloud Bus. Similarly, if you are using Kafka, we don't have to create topics, we don't have to create partition, we don't have to manage offsets, etc. So it's all abstracted to us. And that's why, very important, again, I am repeating, Spring Cloud Bus is just a wrapper above the message broker. Do not use it for critical message where you need full control over topic, creations, retry mechanism, message persistence, acknowledge. If you have all this requirement, don't use Spring Cloud Bus. Only use Spring Cloud Bus which for low volume, non-critical messages like refreshing the config, clear the cache. Which is, you can say that even if it got delayed or if it doesn't success and next time you refresh or next time you clear the cache, it should work fine. So less critical and low volume traffic, you should use Spring Cloud Bus. It is not recommended for critical high volume system because it do not give us a way to control our message broker. So wherever our message broker is, it's just a layer above it, just uses it and pass the message. And internally it just creates some temporary queue, exchange, whatever it does, we don't know. It all abstracted to us. Okay. So understood in what use case you have to use and in what use case scenarios we don't have to use Spring Cloud Bus. So let's do this producer and you can say that listener or consumer in different microservice. Now they are not in same application. So now do a setup. So one thing you know that when they are in different microservice, you need a message broker. So for testing, we have to set up some message broker. So for now, I am using RabbitMQ. So if you have Mac, you can use this command to install the RabbitMQ. If you don't have, and you can, it's very easy to install and start, whether it's Windows and macOS. So very simple. I just install the RabbitMQ and using this command, I started it. So over this localhost and this port, you see that RabbitMQ is started. Username, password, default is guest. So my message broker is started. So first setup is done. Now second setup is publisher. So now I am setting the publisher. So in the pom.xml, we have to add this dependency. We have to tell what message broker I am using. So currently RabbitMQ is following the AMQ protocol. Okay, AMQP protocol. And so that's why I have added this dependency. If you are using Kafka, then you can double check it's Spring Cloud Starter Bus Kafka is the dependency you need. Double check it. Okay. So first thing is we have to have a dependency in the publisher. Second is here, whatever the message broker, you have to provide an access. So host, port number, username, password. Okay. So this I provided so that my producer is able to connect to the message broker. Again, this is just for testing. That's why I have username password here. Otherwise, never put your secret or credentials in application.properties like this. It should always be keep safe in some secret manager or it will be passed to an environment variable. So this is just for testing. Okay. I have an application name, let's say producer service running on port number 8081. And this is one very important where most of the engineers who are working with Spring Cloud Bus faces the problem. each producer, or you can say that each application which is making use of, this is message broker, which is making use of Spring Cloud Bus, it is granted one unique ID, or you can say that bus ID. Okay, why it is important? Now understand with this one. So here let's say application 1, application 2, application 3. There are so many applications. Each application which are connected to a bus, let's say this is a Spring Cloud Bus. Understand that this is a Spring Cloud Bus, all connected through some message broker. Spring Cloud Bus, Spring Cloud Bus. Okay. Each app has a unique ID, or you can say that bus ID. And the format is your application name, colon, port number, colon, some random UUID. It internally generates like this. And any application which is publishing an event, let's say app 1 is publishing an event to a message broker through Spring Cloud Bus. So Spring Cloud Bus has a condition. Hey, application 1, if you are publishing an event, the event should be from you only. You should not publish an event on somebody else's behalf. So whoever is publishing an event, it also passes its ID. Hey, this is my ID. I am publishing it. So Spring Cloud Bus internally has this, whatever the application bus ID which we have given. If you don't give it, internally what bus ID it will compute? Application name, producer-service, port number 8081 and some random UUID which you don't even know. So it will generate this. Okay. So it has application bus ID which it generates, and then whatever we will pass while publishing an event through remote, we have to pass bus ID. So if you just pass, hey, producer-service, so internally it match. Hey, this is what I computed, the application bus ID, and this is what you passed. It didn't match. So means you are not the one. You are publishing on somebody else's behalf. So your publishing event will not even work. It will not even publish. So that's why we takes the control of the bus ID naming. So the bus ID naming I have given is that, hey, this is the application name and hyphen, this is the port number you should use. So now this is the bus ID it will generate. So internally, when I will publish an event, I will also pass this name only. Producer-service port number 8081. So I will pass this only, and internally it will compute the Spring Cloud Bus ID. Now since I have overridden it, it will compute this. So now they both will match and the publish will work. You will get to know where it will use, but this is very important. Okay, so we have given one unique bus ID to this application. Now, this thing done. So we have added the dependency. We have added the application.properties. Now this is my event which I need to publish. So you have a publisher which need to publish an event to a message broker. So this is my event, my remote custom event. Now look carefully that it extend remote application event. So earlier when within a one application we were doing it, it was application event. But we want a Spring Cloud Bus to intercept this event. So that's why it need to extend remote application event. Then only your Spring Cloud Bus would be able to intercept it. So here this is the hierarchy. So serializable, then event object, then it's then application event, extend this event object. Earlier we were using application event, but if you want a remote and want a Spring Cloud Bus to intercept it, then we have to use this. It's again a child of application event only. Okay. Now here one more difference you see is that earlier we have only source, like who is publishing it, like this object, who is the publisher. Now here we have origin service, destination. Very important to understand this too. Origin service, destination. Origin service is who is publishing the event, which application. not this class, not publisher class. We have already covered this in the source. It is this object. So it has about this object information. Origin services, which application is publishing an event? I told you, hey, this is the application which is publishing an event. So we want to give this name. If you give any name, let's say producer-service, internally it will check, hey, whatever the name you have given in the origin service, is it matching with this application bus ID? So currently the bus ID is computed with this. If you don't use this, then bus ID it will compute internally like this: application port columns and random UUID. If this two doesn't match, your publishing will not work. Okay. So origin service is like which application is publishing an event. Destination means this message is intent to which all listeners. So now let's say you have a publisher. You publish an event to listener 1, listener 2, listener 3, listener 4. There are so many listeners. Now let's say in destination we can say that, hey, this message is intent for listener 1 and listener 2 only. If you say that like, okay, doesn't matter, it publish it to all, you can put asterisk or null. So both means that publish to all. And message is nothing like what message you want to publish. Okay, so it just, whatever the message we have, it just fill it up. Okay, you can have more info. This is just like I have only one field message which I want to transform. So I already told you this very important part. Origin service is very important. Okay. So we have created our event message which we have to publish. Now the publisher, which is same, very similar to what we have done in the single application itself. So we have a application event publisher. Again, similarly like one single application. Here I have a method publish. I am doing publish event. Now here I am creating my new remote custom event, passing the source that this is the class object which is doing the publish. This is the origin service ID with information about which application is publishing. So here if you see that I carefully sending the specific bus ID itself. So from the value, from the application.properties, whatever I have configured, the same value I am passing so that internally the condition should get true. You can test like you can pass anything, producer-service. Your publish event will not even work. Okay. And then destination I put asterisk like whoever are the listeners to this bus, pass it to all. And the message. Okay. Very, very similar to application, single application. So now that's publisher is done. Okay. I just added a controller class just to initiate the flow. So has a publish endpoint, which is just initiating the publish, this one. This invoke this method. That's all. Nothing else. So your publisher has setup is done. Your broker setup is done. RabbitMQ. This is done. Publisher is done. Okay. Now we are setting up a listener. In listener also we need this POM because it need to connect to the RabbitMQ itself. Okay. So we have a dependency, and in the application.properties we have provided all the credentials so that it can successfully connect with the message broker. Okay. And this is the application name, consumer, port number running on 8082, different port number. So POM done, application.property done. Now I am adding a listener. So again, everything is same. Whatever we were doing in the same single application, now we are just like listener is present into different application. So event listener. So now here if you see event listener is same, it is listening to my remote custom event. So we can put this class here, this class, right? Which we have to publish message. We can put it into some common place so that both publisher and your listener can access that remote custom event class, or you can duplicate it. Like in both the application, you have this class, but it need to be same. So my recommendation would be you have some common configuration or common, you can say that repo, where you have all the common utilities. So here you can say that my remote custom event class should be there, so that your producer can use this, listener can use this class, same common code. So for testing purpose, I will share the Git link. In that one, even in the listener, I have this class copied. So it's currently I am duplicating it. So this class present here also, this class present here also. Okay. But the motto is that event listener is listening to this event, my remote custom event. Okay, and just printing it. That's all. Yeah, and one last thing. In the listener, whatever the application you have, here you have to use @remote application event scan, and you have to provide the base package. Like, where is this event, remote event present, where I have to look into it. So this package and all its sub package, Spring Boot will scan. Why it is required? Because I told you that this is the flow. Publisher, when publish Spring Cloud Bus intercepted, it serialize it, it's a JSON form, it pass it to the message broker, message broker, it goes to Spring Cloud Bus as listener side, it need to deserialize, means JSON to Java object. Now it need to deserialize, right, JSON to Java object. So while deserializing it, it need to find out this Java object. Okay, so it need to find out this my remote custom event. So where it has to look, it doesn't know. So that's where with remote application event scan, we are telling, hey, either you can look into this package or all its sub packages. So that deserialization should work properly and it able to find this class. Okay. That's all. So our listener is also set up. Now let's start publisher and listener. Okay, and let's start it on our code also. Let's do that. So here, let me stop it first. So this is my publisher. All the code which you are seeing, it's exactly the same thing which we have go through. I've also shared it into the Git link. So now let's see this. I am starting my producer app and this is my consumer app. Let me start my consumer app 2. So my producer app is running on 8081 here and the consumer app is running on 8082. So here if you see producer app, this one is consumer app 8082, it's up, and producer app 8081 is also up. So this step we have done. Now let's invoke the publisher. So here this is the publish. Okay, so I am invoking 8081. This is our publisher running and I am invoking the message send. Okay, event publish. Now let's see the logs. So consumer, so I'm checking the consumer app. Here if you see, received a remote event in client service hello world. So this is what it printed. Receive the remote event in client service and this message. So our listener, even though we invoked the publisher, it successfully, our consumer app able to listen it. Okay, so hit it again, you will see received in our consumer app which is running on 8082 and which we are hitting 8081. Okay, so our setup is working fine. So this is, we have seen it. So properly working fine. So now we understood how Spring Cloud Bus is working. Now the real world use case is dynamic refresh. So now this is where we finished our previous lecture, that earlier our without Spring Cloud Bus, this is our setup for the configuration. When we manage a central configuration and we have to dynamically refresh, this is our setup. On config server, we have to invoke the refresh and all the 100 services we have to invoke it. But with the Spring Cloud Bus, this is going to be our setup. we have config server, which now act as a publisher, which going to publish an event to some message broker, let's say Kafka, and from this all microservices will listen and their event listener method will get invoked. Okay, and here in the config server, instead of normal refresh, we have to invoke actuator bus refresh, because bus refresh, it will publish the event. We will see that. So first thing first, like you have to see the previous videos. Otherwise, because many things we have already set up the central configuration. We have already set up central config servers, this microservices. Everything is done. We are now just integrating the Spring Cloud Bus. So if you want a complete detail, kindly check out the central configuration and refresh scope, dynamic refresh scope. Okay. Then after that, this setup would be clear to you. So here at the config file, no change. It's a Git repo which holds our application dot properties. So no change in that one. In config server, now see what change I am doing. So everything we have previously, I am just adding the AMQP message broker support. Okay. So that our config server should be able to connect to the message broker. And in the application.properties, I have added the message broker credentials, and also one more, since we have to invoke bus refresh endpoint, so that's why I am exposing it. I have already covered that in the actuator, like, or in the previous videos. So you can check it out. That's why I'm saying it has a prerequisite. Spring Cloud Bus has a prerequisite on cloud configuration, central configuration, and refresh scope, 2 videos. Okay, so I am exposing this bus refresh endpoint. That the minimal change I have done into the config server. That's all. The dependency and the property. Now you might be thinking, hey, where we are publishing, where we are doing dot publish. Okay, that is within this API. When we do /actuator/ bus refresh, right? Bus refresh. Internally, we all framework provides us the code for publishing an event to this message broker. I will show you which class does that. So now publishing is done. Now the microservices, again, dependency, same message broker, and in the application.properties, the credentials so that they can connect. Okay. Now with this dependency, our Spring Cloud Bus dependency has come. So no change in controller, whatever we have previously, no change in configuration properties, which we have to dynamic refresh. That's all. So here, if you see, our consumer is also done. We have just provided the Spring Cloud Bus dependency and the message broker details. Now you might be listening, hey Shans, where is @event listener? So that it can listen to the event, whatever it will publish. That is also provided by the framework. We don't have to write it. I will also show you how. So let's see that. So start the server for both config server and orders microservice. Again, let's see this one so that it would be clear. So I am stopping this consumer. I am now moving to refresh scope. I have everything updated into the Git. Okay. So you can refer the code. So refresh scope has 2 modules. One is server and one is order service. So let me start the, so yeah, and one more thing, currently the central config, let's say, has this hello from order dev. So here, so this one, the central config hello from order dev. So let me push this to this and branch refresh scope -test. So testing Spring Cloud Bus. Okay, so currently this dev properties is holding this hello from order dev. Okay, now we have to start the server. for our config management. So let's say, let me check its property. It is currently listening to the main, but I have changed on refresh scope test. Okay, so bus refresh is there, all endpoint is there, all looks good. Only this, if you have seen the previous video, you know what's the use of this. It is fetching the properties from this branch of this config. So I am starting the server. Tomcat started on 8888. So my server is started. Now I am starting the different application microservice. (8080). So we have done this 2 steps. So our order application is started on 8080 and our config server is started on 8888, and we have this currently file stored in our central config. Now let's invoke the order microservices. So this is the endpoint we have exposed in order microservices, right? So /fetch. So now we are invoking this. So here /fetch. So here when you invoke it, what you are getting? Hello from order dev. This is what we have currently. Okay, so it's properly fetching the property value hello from order dev. Now update the property in the central config. Okay, so now what I am doing is, in the central config I am changing it. This is updated something. This is updated, and now I am just committing it and pushing it again on the branch. So this is updated. So I have updated the value from this to something like this is updated. Okay. Now let's hit the order API again. So let's hit the order API again. You will see that same thing. Hello from order dev. Counter value is 2 means it we have hit the second time. We haven't restarted or anything. So the same server is running. But you see that it is not yet updated. It is expected. Same old value. Because we haven't invoked actuator /bus refresh. Bus refresh. Now let's invoke actuator /bus refresh endpoint on config server. Okay, so here if you see config server running on 8888, now I am invoking actuator /bus refresh. Send. So yes, success. Now I have done this step. Okay, so I have invoked on config server 8888. Now let's hit the order API again. So in order API, I haven't invoked the /refresh endpoint. I am just again calling /fetch. Done. What I am getting? Hello from order dev. This is updated. So now here if you see the latest config value I am getting without even I have invoked /refresh endpoint or / anything. So how does it work internally? Because we have seen that in our config server, we are not doing publish. Who is publishing it? And in our order, we are not putting any @event listener. Who is listening it? So this is how it works internally. So on the config server, when we call bus refresh endpoint, internally it invokes this endpoint, refresh bus endpoint. It is annotated with like /actuator /bus refresh. So this endpoint will get invoked. It's already present into the framework. Now here if you see, this method will get invoked, and what it is doing, it is publishing an event. Which event? Refresh remote application event. So this is the source. This is the bus ID it is passing. Destination is null. Pass it to all. Very important. Now here if you see, one question should come to your mind. Hey Shreyansh, it is directly publishing it. So the setup is like that. So we have a config in Git repo. We have here central config server which fetches from the config, and from this config server our application fetch. Order application is fetched from this config server. But from this logic, what I see is that when I invoke the bus refresh, it directly do the publish. Hey, so it is, sorry, not directly to the order server, it message to the broker, and from this message broker, order application. So this is our Spring Cloud Bus setup. Hey, config server is directly doing publish, but it hasn't done refresh itself. It should refresh its properties first, right? Then only you should publish it. Because once you publish it, the application will catch it and they will ask, hey, config server, give me the latest property. But config server hasn't done the refreshing yet. Okay, because what code I am seeing is when I invoke /bus refresh, it is just publishing an event where it is refreshing itself. That's Spring Cloud Bus flow. Understand that? This will become more clear. So this is what happening. When you invoke /bus refresh, our config server control goes, okay, this part, this class, and it will publish an event, and it will go to the message broker. What event? Refresh remote application event. This it will publish. Now what's the destination? Null means all application which are listening to this bus. So in this bus, even the config server is listening itself. So this message broker will pass it to all the application which are listening to this bus. So it will pass it to config server, it will pass it to the order microservice, because this is also listening to the same bus. Okay. So it will pass it to the both. Now in the config server, there is a class already, again framework class, refresh listener, which has this method, context refresh dot refresh. So in the refresh listener, there is something called @event listener present. That will get invoked and that will do context refresher dot refresh. So it will fetch the config from the Git repo. Similarly, order microservices refresh listener, which is already present into the framework class, has this event listener present, which does context refresh dot refresh. So this event listener is listening to this event. So that will do refresh and it will fetch the latest config from the config server. So you might be thinking that, okay, now I understood that the same message is broadcasted to config server and they both have a listener already present. So they are already doing the refresh config. Okay. But what if order microservices, it receive first? Meanwhile, config server hasn't done the refresh. So generally, let's say that, assume that if the event is broadcasted and order service is going first, its listener has invoked first, even though it hasn't done its refresh completed. And when it refreshes called, it will invoke the config server. Hey config server, give me the latest data. In that scenario, since config server hasn't completed its refresh yet, it make a fresh call to config, fetch the latest and then give it to order. So this is how it's working internally. So I know it's a lot of information, but if I cover it very high level, that without covering how in one application it works, then a custom event will work in different microservices, and then how it's handled in dynamic refresh. If I cover directly dynamic refresh and then just say that, okay, we just need this dependency and all done. So here if you see that all you need is this dependency, in order service all you need this dependency, done. Dynamic refresh done by Spring Cloud Bus. But how is it working internally? That will keep on bugging us. So I hope this is clear. If you have any doubt, let me know. We can discuss further. Bye.